In this video, we're going to talk about something called the determinant of a matrix. There's one very important thing you need to know about determinants before we start computing them, and that is that you can only take the determinant of a square matrix. In this video, we'll talk about what determinants are, and then I'll show you how to compute the determinant of a 2 by 2 matrix. First of all, let's talk about some vocabulary. If I want to take the determinant of matrix A, or if I want to write an expression, a sort of linguistic expression for the determinant of a matrix A, I'm going to do that like this. DETA means determinant of matrix A. You might see determinant of A with the A in parentheses. You might see it with the A in matrix brackets, because that's oftentimes how we will talk about a generic matrix. It doesn't list the components of the matrix, but the brackets sort of indicate that there are components in there. This thing represents a matrix. Most often, though, you'll see it written like this. It kind of looks like the absolute value of A. It's not. The numerical value that we'll come up with for the determinant of A is not necessarily going to be a positive value. But this notation is common, and in context, you'll come to understand what it means. And it means the same thing as these other three notations. Additionally, if you have a matrix A, let's just put some generic entries in there for now, A, B, C, and D, some generic matrix entries. Then if I want to take the determinant of A, I'm going to use the entries of the matrix, and I'll draw these vertical bars either side of the entire matrix. So we have to be careful now with our notation. This entity here, the matrix with the components A, B, C, and D, is not the same as this entity here, although the notation looks very, very similar. In fact, I've not done a very good job of drawing that bracket. So we have to be very, very careful. This is not the same thing. This entity here is a matrix that has 4 components. This one is a numerical value once it's computed. It's the numerical value we call the determinant of that matrix. But these two things are not the same. Okay, let's talk a little bit about how to find the determinant of a matrix. Let's start with matrix B, and I'm going to make that the matrix 1, 2, 3, 4. Then let me rewrite that. The determinant of B, which I can write this way, or I can write this way, I can write it a lot of different ways, is equal to the matrix entries 1, 2, 3, 4 in these vertical bars. And what needs to happen now is I need to compute the determinant using this. This is just another notation saying this is the determinant of B, this is the determinant of B. It's going to be some numerical value. This is also the determinant of B, but what is that? And here's how we find that value. We're going to start in the top left-hand corner of the matrix written in determinant form, and by that I mean that we've used these vertical bars here. And we're going to cross our way down through the matrix and out the other side. And as we do that, we're going to multiply those numbers. So what I'm going to get for my first value here is 1 times 4, which is 4. And then to use the other values, I'm going to go cross through the matrix in the other direction. So I'm going to start in the top right-hand corner, and I'm going to work my way through the matrix, multiplying as I go. So here I'm going to get 2 times 3, which is 6. And the determinant then is this 4 minus that 6. So here my determinant is -2. Okay, I'd like to do another one for you. Let's take matrix C, and let's go 2, 4, 7, 14. And so the determinant of C is the same entries, 2, 4, 7, and 14, but with vertical bars. And to compute this determinant, I'm going to multiply these two numbers. That gives me 28. I'm going to multiply these two numbers. That gives me 28. And I'm going to subtract them. So the determinant here is 0. Now, here's an interesting thing. This is one of the ways in which determinants are actually useful. I could have done this matrix. In fact, probably I should have done it a slightly different way. I might have been better off saying, for example, 2, 7 for 14, and then this would have become clearer. I'm still here going to have 2 times 14 is 28. And here I'm going to have 7 times 4, which is 28. I'm going to subtract those, and that's going to give me 0. So I think it's clearer now, though, in this form, that what I've got here, remember a matrix is just a system of equations in that, in matrix form, right? So since what I've got here in this row is a scalar multiple of this row, the system of equations that this matrix came from does not have a solution, does not have a unique solution, right? So there are an infinite number of solutions. There are free variables. So this is one of the ways in which determinants are useful. And this is the way we compute a 2 by 2 determinant, or the determinant of a 2 by 2 matrix. It's actually really straightforward. I'm going to do one more just for good measure, and then we'll move on to something a little bit more interesting. So here I have matrix M, which has entries 0, -1, 3, and 2. And the determinant of M, which I could also write this way, is the matrix with components 0, 1, 3, 2 in these vertical bars. And I'm going to multiply these two numbers and get 0. I'm going to multiply these two numbers and get -3. Then I'm going to subtract them, and I end up with 3. So that determinant is 3. So that's how you find the determinant of a 2 by 2 matrix. It turns out that one of the easier ways to find the determinant of a 3 by 3 matrix involves using the determinant of a 2 by 2 matrix. So it's actually pretty useful, pretty valuable to be able to do this fairly quickly. And you'll see that when we get to the 3 by 3 matrix in a few minutes here. I do want to point out that there's a formal definition of the determinant of a 2 by 2 matrix. And that is that for a matrix A, which has entries A, B, C, and D, the determinant of A is equal to the product AD minus the product BC. And this is the formal definition, but as you can see, the way we can get that is to multiply these two values and then multiply these two values and subtract them. Okay, so all I've done in showing you the computation first is show you how the formula comes about.